Welcome back, everyone. Make sure to subscribe to my channel for more videos. The topic of this video is arrangements of electrons, where we're going to describe how electrons are grouped within atoms. So, electrons can be divided up into what are called electron energy levels. And electron energy levels, or electron shells, are going to be fixed distances from the nucleus where electrons can be found. Now, energy levels can be thought of almost like steps in a staircase, whereas you go up the ladder, you get farther from the nucleus. And you can only stand on one step of the ladder at a time. And it's the same thing with electrons. If you cannot step in between the spaces of the steps, you also cannot have electrons between these energy levels. So electron energy levels are going to change the maximum number of electrons that are allowed in each level. And it continues to increase as you get farther from the nucleus. So in the first energy level, you can have a maximum of 2 electrons. In the second level, 8 electrons, third, 18, and the fourth, 32. So, while the maximum number of electrons in energy levels while the maximum number of electrons in the energy levels and the connection to the periodic table may go beyond the scope of this class for the third and fourth energy levels, you can look at the first two. So in the first energy level, remember that we have 2 electrons. So 2 electrons, and in the first period, if we count up the number of elements in that first period, we have 2, which again matches the number of electrons in the energy level. For the second row, or the second period, if you count up the number of electrons, you will have 8. Okay, so again, 8 matching the second energy level. And for the third energy level, if we drop down and include the transition metals in row 4, and add all of those elements up, you will get 18 for the third energy level. Now, the third and the fourth energy levels and their connections to the periodic table sort of go beyond the scope of this class, but that may help you see that there is a connection between the energy levels and the periodic table. Now, if we want to look at the electron arrangements for a specific element, we first need to determine what is the total number of electrons. And the total number of electrons for that element, remember, comes from the atomic number. So for fluorine, looking at the periodic table, fluorine is here. And remember, the atomic number is the whole number that it gives you for fluorine, which is 9. Lithium is 3. So again, if we find lithium on the periodic table, you can see that lithium has 3 electrons. Now, once we determine the total number of electrons, we can fill up each energy level until it reaches its maximum number of electrons. So remember that the first energy level were 2 electrons, second, 8 electrons, and third were 18 electrons. So, for fluorine, we need a total of 9. And in that first energy level, we're going to place 2 electrons. Okay, so the electron arrangement that you would write would be 2 and then a comma to separate each energy level. In the second energy level, we have 7 electrons left, and all 7 can fit in the second energy level because remember, the maximum is 8. So since 7 is less than 8, all 7 can fit in that second energy level. So the the final electron arrangement for fluorine would be 2, 7. Okay, for lithium, we have 3 electrons. The first 2 fit in the first energy level. So lithium starts out with 2, and it has a total of 3. So we have 1 electron left, and we fit that in the second energy level. Okay, now all the numbers that you write out for the electron arrangement should add up to the total number of electrons from your atomic number. So 2 plus 7 should equal 9, and 2 plus 1 should equal 3. All right, let's do one more. So what is the electron arrangement for sulfur? Okay, the first step is to find sulfur on the periodic table. Sulfur is right here. It has an atomic number of 16. And then remember the maximum number of electrons for each energy level, which was 2, 8, and 18. Okay, we fill up the first energy level, which is 2 electrons. We still have 14 left, which is more than 8. So fill up that entire second shell, and now we have 2 plus 8, or 10 electrons, and there are 6 remaining. So those 6 remaining will go in the third shell. Okay, and again, all of the numbers in your electron arrangement, 2 plus 8 plus 6, should add back up to 16. The last topic in this section are valence electrons. Now, valence electrons are those special electrons that are in the outermost shell or outermost energy level of an atom. Okay, so in fluorine, that would be the electrons on the outside. And for lithium, it's the electrons also on the outside of that shell. The valence electrons can determine many of the properties in atoms, so knowing the number of valence electrons can be extremely important for each element. And the nice thing is that we can determine the number of valence electrons for main group elements by looking at that periodic table. Now, if you remember, the groups, while they could be listed 1 to 18, there was a second numbering scheme that involved using A's and B's. And it went from 1A and 2A, skipping the transition metals, and then picking back up with 3A all the way out to 8A. Okay, so if you will number the groups, skipping the transition metals, that helps you determine the number of valence electrons in that group. So in group 1, we'll have 1 valence electron. In group 2, 2 valence electrons. And then skipping over to 3A, we would have 3 valence electrons. And you can keep going with carbon would be 4, nitrogen 5, oxygen 6, fluorine 7, and helium 8. Okay, and that applies to every element within the group or within the column. So the last example that we'll give, determine the number of valence electrons for sulfur. So your first step is to ask, which column is sulfur in? Or which group? Using the A and B numbering system. Okay, we see that sulfur is right here underneath oxygen. And so looking up, remember, we want to use the column number 6A, or 6. So sulfur has 6 valence electrons. Okay, that is it for this section. Again, please subscribe for more videos, and I'll see you next time.